In this video, we will talk about eclipses, how they came up, how they help, how ancient civilizations saw them, and much more. So without further ado, let's go to the video. An eclipse occurs when a celestial body, such as the moon or sun, enters the line of sight of another celestial body, such as Earth, temporarily blocking the light or visibility of the eclipsed object. There are two main types of eclipses: the solar eclipse, where the moon blocks the sun's light, and the lunar eclipse, where the Earth is between the sun and the moon, projecting its shadow on the moon. Eclipses do not occur every month due to the tilt of the orbits of celestial bodies. But when they align in a specific way, we can observe these fascinating astronomical events. Eclipses have played a multifaceted role in history and culture, influencing religious beliefs, scientific practices, political decisions, and even artistic expressions in various civilizations around the world. These celestial events continue to fascinate and inspire people to this day. Solar eclipse. A solar eclipse occurs when there is an almost perfect alignment between the Earth, the moon, and the sun. In the new moon phase, the moon is between the Earth and the sun, partially or completely blocking sunlight. Solar eclipses do not occur with every new moon due to the inclination of the moon's orbit relative to the Earth's orbit around the sun. The lunar orbit is tilted relative to the Earth's orbital plane, so the three bodies must be aligned in a specific way for a solar eclipse to happen. There are four types of solar eclipses. There is a total solar eclipse, which occurs when the moon completely covers the solar disk, completely obscuring the view of the sun from certain areas of the Earth. During a total solar eclipse, the sun's light is blocked by the moon, revealing the solar corona. The annular solar eclipse, in which in this case, the moon does not completely cover the solar disk. When the moon is furthest from Earth in its elliptical orbit, it appears smaller in the sky and does not fully cover the sun. This results in a ring of sunlight visible around the edge of the moon. Partial solar eclipse. This happens when only a part of the sun is obscured by the moon, while the rest remains visible from a certain location on Earth. And the last one is the hybrid or annular total solar eclipse. This is a rare type of eclipse that begins as annular and turns into total or vice versa, depending on the location along the center line of the eclipse. A solar eclipse occurs when the moon passes between the Earth and the sun, blocking some or all of the sunlight. For a solar eclipse, the moon must be in a specific position in its orbit around the Earth so that it aligns directly between the Earth and the sun. Additionally, a solar eclipse occurs during the new moon phase. During this phase, the moon is between the Earth and the sun, with the illuminated side of the moon facing away from the Earth and therefore not visible from the Earth. The moon's orbit is tilted relative to Earth's orbit around the sun. This means that most of the time, the moon passes above or below the plane of Earth's orbit around the sun. A solar eclipse only occurs when the moon crosses Earth's orbital plane during the new moon phase. The distance between the Earth and the moon also plays an important role. Because the moon's orbit is elliptical, the distance from the moon to Earth varies over time. A total solar eclipse occurs when the moon is closest to the Earth, and an annular solar eclipse occurs when the moon is furthest away. The moon's apparent size is crucial. During a total solar eclipse, the moon must appear large enough to completely cover the solar disk. During an annular eclipse, the moon should appear smaller, resulting in a ring of sunlight around the edge. When all these conditions are met, a solar eclipse can occur. During a total solar eclipse, there are two main phases: the totality phase and the partiality phase. During the phase of totality, the moon completely covers the solar disk, blocking all direct sunlight. From certain regions on Earth, people experience complete darkness of the day for a short period of time. Furthermore, the totality phase is relatively short, usually lasting just a few minutes. Before and after the totality phase, there is the partiality phase, where the moon covers only part of the solar disk. During this phase, people see a portion of the sun still visible, with a portion of the sunlight being blocked by the moon. The partiality phase can last several hours, starting when the moon begins to enter the front of the sun and continuing until it moves completely out of the way. Observing a solar eclipse without adequate protection can cause irreparable damage to the eye due to the harmful intensity of the sun's rays. Wear special glasses designed specifically to observe the sun. These glasses have appropriate sunscreens that block most dangerous sunlight. If you are using telescopes or binoculars to observe the eclipse, be sure to fix appropriate sunscreens at the front end of these devices. Do not look through telescopes or binoculars directly without proper sunscreens, as this can cause serious damage. There is your vision. Now let's talk about the lunar eclipse. A lunar eclipse is a fascinating astronomical phenomenon that occurs when the Earth positions itself directly between the sun and the moon, thus blocking part or all sunlight that normally illuminates the moon. This event results in a shadow projected by Earth over lunar surface, causing a remarkable variation in the brightness and coloration of the moon during different phases of the eclipse. But how does it happen? A lunar eclipse occurs specifically during the full moon phase. During this phase, the moon is opposite to the sun in relation to the Earth, causing sunlight to be directly on the visible face of the moon. A lunar eclipse happens when the Earth, the moon, and the sun are aligned so that the Earth is between the sun and the moon. The shadow of the Earth is projected into space, and the moon gradually enters this shadow. The earthly shadow is divided into two main regions, the dim and umbra. In the dim light, sunlight is only partially blocked, resulting in a subtle decrease in the moon glow. In the umbra, sunlight is completely blocked, causing a darker and more dramatic region. The moon enters the dim light of the Earth, starting to lose some brightness. This stage is called the penumbral. The moon penetrates the umbra, resulting in a darker and visible shadow on the lunar surface. This stage is called partial, and if it continues, it becomes total. During all, the moon is completely inside the umbra of the Earth, assuming a reddish color due to the dispersion of sunlight through the Earth's atmosphere. After totality, the moon begins to emerge from the umbra and eventually exits the penumbra, gradually restoring its normal brightness. The reddish color that the moon takes on during a total lunar eclipse is a fascinating phenomenon and is often referred to as the blood moon. This peculiar coloration occurs due to a process called atmospheric dispersion, which is influenced by the Earth's atmosphere. Earth's atmosphere acts like a scattering lens, scattering sunlight. During a total lunar eclipse, when the moon is completely immersed in the Earth's shadow, umbra, sunlight that reaches the moon passes through the Earth's atmosphere before reaching the lunar surface. Therefore, the moon acquires this reddish color during a total lunar eclipse due to the selective filtering of sunlight by the Earth's atmosphere. This coloring adds an aesthetic and poetic element to the celestial spectacle, making total lunar eclipses notable and impressive events for terrestrial observers. Eclipses have been objects of fascination and interpretation in several ancient cultures, often being considered events of spiritual, mythical significance, or even as omens. Interpretations vary significantly between different civilizations. In Greek mythology, solar eclipses were often interpreted as events associated with the displeasure of gods, such as the god Apollo. They were seen as signs of his dissatisfaction with mortals. In ancient China, astronomical records were meticulous. Eclipses were often seen as omens of significant events and were recorded as important for government and predicting the future. In Chinese mythology, the idea of a dragon devouring the moon was often associated with lunar eclipses. The dragon represented cosmic forces at work. The Aztecs considered eclipses to be ominous events. It was believed that the sun was attacked by celestial monsters, and human sacrifices were performed to appease the gods. The Mayans, a culture highly advanced in astronomy, had the ability to predict solar and lunar eclipses. They viewed these events as interactions between celestial deities. In Hindu astrology, eclipses were often associated with Rahu and Ketu, mythical entities that were considered the heads of a demon. Eclipses were seen as moments of danger and impurity. Different Native American tribes had their own legends and myths associated with eclipses. Some viewed eclipses as spiritual events, while others might interpret them as cosmic confrontations. In many cultures, the unknown and inexplicable of eclipses inspired a mixture of fear and fascination. Often, events were interpreted as divine messages or as the interference of supernatural forces. During a total solar eclipse, when the moon completely covers the sun, the solar corona becomes visible. The corona is the outer layer of the sun's atmosphere. Studying the solar corona during an eclipse offers scientists valuable information about the physics of the sun and its processes. Lunar eclipses provide opportunities to study the moon's surface. When the moon is in the Earth's shadow, lighting conditions are ideal for detailed observations and for mapping specific regions of the lunar surface. Solar eclipses provide a unique opportunity to study solar activity. During an eclipse, observations of the solar corona can help map the distribution of temperatures and densities in the solar atmosphere. Solar eclipses have historically been used to test theories of gravity, such as Einstein's theory of general relativity. Changes in the path of light from stars close to the sun during a solar eclipse have been used to verify theoretical predictions. Eclipses provide opportunities to test and improve new astronomical instruments. Scientists often use eclipses to test new technologies and observe celestial objects in ways that would not be possible during normal daylight. In short, eclipses play a vital role in modern astronomy, providing unique opportunities for scientific research, testing of fundamental theories, and public engagement. They serve as special moments that unite science, culture, and the wonder of the universe. In short, eclipses, fascinating and multifaceted cosmic phenomena, have not only captivated the human gaze since ancient times, but continue to play vital roles at the intersection of science, culture, and the wonder of the universe. From the precise astronomical conditions that orchestrate these events to the cultural interpretations that transcend the ages, eclipses bridge the gap between scientific knowledge and human wonder. So if you like the content, please smash that like button and subscribe so you don't miss the next videos. Bye!